Hey there, 6th grade. In this video, we'll be talking about congruent figures, and I want to start this video by asking you to look at the two patterns you see above. I want you to ask yourself, which center circle do you think is larger? Do you think it's the one on the left or the one on the right? Well, the answer, it might surprise you, is that both of those circles are the same size. And whenever you have two shapes that are the same size, we call those congruent shapes. So even though it appears that the right center circle is larger than the left center circle, they're actually congruent. This is what is known as an optical illusion. So let's analyze that a little bit more. If I start to cover up the outer circles in each of these patterns, you might start seeing that those center circles are actually the same size. Okay, so there's the left circle, and here's the right circle. So taking away those outer circles lets you see that those circles actually are the same size. And so this video is about how to tell whether or not figures are actually congruent to each other. And one way to do that is by determining whether one figure will fit exactly over another one. And so that's what we're going to practice here in examples 1 and 2, is identifying whether or not figures are congruent to each other. Let me get rid of those boxes I drew. There we go. And we'll go down to examples 1 and 2. So in example 1, you see a checkerboard, and I want you to take a moment and look for any figures that appear congruent. And in this figure, I see two types of figures that appear congruent. Okay, so first of all, the squares on the checkerboard. Okay, the squares on the checkerboard appear congruent because I could take one square and put it directly over another square. And also, the checkers themselves are congruent. I can put one checker on top of another checker, and so those would be congruent figures. Okay, let's look at example 2. Here there is a target, and so ask yourself, do you see any congruent figures in this target? Okay, the answer to this one is no, there really aren't any congruent figures in this target, and that's because the only figures in this are the rings, and the rings on the target are not congruent. Okay, as you go inwards, each ring gets smaller and smaller and smaller. So the definition of congruent figures is you can fit one directly on top of another one, and these are not congruent figures. They're all different size rings. Okay, so that was a couple of examples on how to identify congruent figures just by using that basic definition of putting one right on top of another. But there's a more formal definition for congruent figures that I want to take a look at, and that's if all of the corresponding sides and angles are congruent to each other in a polygon, then the actual polygons are congruent to each other. Okay, so we'll get to what this word corresponding here means, but I want to start by looking at triangles. So for triangles in particular, the corresponding angles will always be congruent if the corresponding sides are congruent. And whenever you have your corresponding sides congruent in two separate triangles, you can use what's called the side-side-side rule. And what this rule says is if you have two triangles and the corresponding sides are all congruent in both triangles, then both triangles are congruent to each other. So for triangles, you only need to determine whether all three corresponding sides are congruent to each other. So let's look at a couple of examples let's look at one example, should I say, of the rule applied on the back. So here you see two triangles drawn. There's triangle ABC on the left and triangle EFD on the right. And our job is to determine whether these triangles are congruent. I'm going to start this process by flipping triangle DEF so that it looks like triangle ABC, and so that means I need to make it so it's facing in this direction. Okay, so now I'm going to relabel the sides and the vertices. So now my side that measures 4 meters will be here. My side that measures 5 meters will be here. And my side that measures 3 meters is still down below. And so now I'm going to relabel the vertices as well. So point E is still up here. Point D was directly below point E, so that's here now, and then point F would be over here. So now that I have these two triangles drawn and facing the same direction, I'm going to match up my corresponding sides. Corresponding sides are just sides that when your figures are in the same, going the same direction, they are in the same place on the figure. So side AC corresponds to side DF in these two triangles. And side AC measures 3 meters. And side DF also measures 3 meters. So these two corresponding sides are equal to each other. Okay, let's look at side AB now. Side AB corresponds to side DE over here, and both sides measure 4 meters. So those two corresponding sides are congruent to each other. And finally, side BC corresponds to side EF, and both side BC and side EF measure 5 meters, and so those two corresponding sides are congruent. Because all three pairs of corresponding sides are congruent to each other, we can say the following. We can say that triangle ABC is congruent, there's our symbol for congruent, remember, to triangle DEF. And we can say that because of or by the side rule, which I like to abbreviate as SSS. Okay, side rule, which just says that if all of the corresponding sides in a triangle are congruent, then the actual triangles themselves are congruent. Okay, so that's triangles. For polygons with more than 3 sides, so quadrilaterals, pentagons, hexagons, etc., it is not enough to compare the measures of their sides. We also have to look at the measures of the angles. And so the reason for that you can see below. In this figure here, we have a rectangle, and we see that its top and bottom sides measure 120 meters, and the left and right sides measure 70 meters. In the figure on the right, we have a parallelogram, and even though the tops measure the same, 120 meters, the bottoms measure the same, 120 meters, and then the left and the right sides measure the same, 70 and 70. These are not congruent figures because the angles are different. In the rectangle, all of the angles are 90 degrees, but in the parallelogram, we don't have 90-degree angles. We have 145 here and here, and 35 here and here. So with figures that have 3 or more sides, looking at the sides is not enough. You also have to look at the angles, and the corresponding angles must also be congruent. Okay, finally, let's say we know that two figures are congruent. And remember, they are congruent if they have the same corresponding sides and the same corresponding angles. So if we're told two figures are congruent, then we can use those facts to work backwards and find missing measures in the figures. So that's what we're going to practice here in examples 4 and 5. We're going to determine the missing measure in each set of congruent polygons. So in example 4, we have two trapezoids, and we're asked to find the missing angle measure here. So to find this missing angle measure, I just have to look at its corresponding angle in the trapezoid to the left. In the trapezoid to the left, the corresponding angle is 93 degrees, and so that means that this angle must also be 93 degrees, since we're told in the directions that these are congruent figures. Okay, and number 5, I'm going to do the same thing. This time I need to find a missing side here. And to do that, I'm going to redraw my figure on the left to look like the figure on the right. Okay, these are both pentagons since they're 5-sided. So redraw the figure on the left now, and now the figure on the left looks like this. This side is 3 centimeters. The bottom now would be 4, the right side 5, and then here we have 3, and here we have 2. So this missing side that I circled in blue corresponds to this side here, which is 3 centimeters. All right, if you have any questions over this video, make sure you have those written down for the next time. And until then, have a nice day. You're all wonderful people.